Ramón with his talk about limiting side effects of applications at compile time.
Hello to the few people that actually show up to my talk. In this talk I'm going to talk about how we can limit side effects of application at compile time. So a bit about myself to the person that might not know me. Why is this relevant and which benefits do we actually get about limiting the side effects of our applications? I will try to show a demo and where I will connect to the OpenStreetMaps and also to the Norwegian Meteorological Institute. And you might see some large hexadecimal numbers, so keep those in mind to the end if you're able to remember those, but I will have them in the summary. I'm a believer of sharing stuff in a copyleft manner, so I'm normally always using Creative Commons and share alike license. So a bit about myself. I got answer here about my name, so yes, I'm a half Spaniard and half Dane, and I say this is why I speak Spanish with Klondike and Dane with the organizers. I have a computer science degree with minor in mathematics, and at the moment I work for my own company where I try to solve the problems related to the EU GDPR and with this concept called uniprocesses. I use also a copyleft license, but this is a bit more permissive than the usual one, and it's because when you deal with a public institution and private companies, you have to have in mind that they also have some intellectual property that you have to live up to. For the most, I work in Haskell and I work a bit in Elm, but I got more and more disappointed with Elm every time there's a new release, so this is why I'm trying to skip or switch to PureScript. Like I say, I'm a believer of copyleft licenses, so I'm a member of the Free Software Foundation for about 12 years now. And I'm a really happy functional programmer person, so I made this meetup group in Copenhagen, which has been ongoing since 2013, and this slide, I'm going to put it on my blog. So just to see, I can see there's a bit more people, but just to see, or just so we're all on the same page, is that I don't expect you to know what Haskell is, or how to use Haskell, or how to even code in Haskell. But normally, and we are in this kind of audiences, it's always good to see who actually is a developer, and of those developers who actually use statically typed programming languages. So how many people here develop on a daily basis? Okay. And how many people rely on statically typed programming languages? Okay. So like I said at the beginning, in this talk, what I will try to do is I will actually show you, and also in the demo with the code, that it's actually possible to limit the side effects of your application so it's not able to do all kind of side effects. And this is something that we can do at compile time. So for the people who don't develop, when we say compile time, is that we actually take some source code and we translate that into a binary that is executed by a system. So also I will mention why is this relevant and which benefits can you get out of this. And normally when I do a talk, I appreciate if you note your questions and then you ask it at the end, because then the talk will be a bit more fluent. So, as I mentioned in the what's called this synopsis or description of the talk, I mentioned this tool called Haskell, and if you take like the definition of Wikipedia, it's actually a standardized, general purpose, purely functional programming language, which is lazy and is strongly typed. So some of these words might sound familiar for you, but I would guess that both lazy and purely functional might sound a bit like, wow, what is that? So lazy is, compared to most programming languages which are strict, is that if a computation, an application is not going to be used, so we just say let foo equals 42 times 42. If I don't use that foo in the rest of the application, Haskell will not evaluate that calculation. It will just skip it. So this is what we mean with lazy. Also, like Haskell has been like an academic language, and it has been used many places in many universities. But thank you to companies in the States like FP Complete and Galois, and in France, Twig.io, because they provide consultancy service with Haskell. It's becoming to the industry a bit more. So the thing about this purely functional programming language, the whole concept about effects versus purity. So Haskell, and this is why I ask about people who use statically typed programming languages, is normally if you use Java or you use C++, you will not be able, if you define a type to be an integer and you define a type to be a string, you will not be able to add those types together because it's two different types. So if you just have that concept in mind, this is more or less what Haskell does. So what it does, it says this part of the code does effects and this part of the code does not effects. This is the pure part of the code. So pure or purity in code can actually be understood as if you make a function that is pure, if you give it the same input, you will always expect to give to receive the same output. While that calculation is being done, this function should not be able to mutate anything or do any kind of interaction with external devices, I/O devices. So I normally make this table here, and it should be read as parent code branches call children. So if your parent code branch has effects, you will be able to call both code branches that has effect, but also code branches that doesn't have effects, which is pure, right? The thing with Haskell is once you are in a pure realm, so the parent branch is pure, you can call other pure branches, but you will never be able to call impure branches. So as the talk before in the morning, XKCD for the win because they always have the right one. So this funny thing that code written in Haskell is warranted to have no side effects, and this is because no one will ever run it, right? So if you just go back to this one, let's say our application is 100% pure, right? If it's 100% pure, we will never be able to interact with I/O devices. So that would be a bit of a downer, right? Because then we will make our algorithms, we will actually run the application, but because we're not able to put any kind of input and we're not able to read the input or the output, it would be just a waste of time, right? So we will just see the computer getting warm or hot, and then it will stop at some point. So that would be totally useless, right? So the concept of Haskell is that we always start from an impure world. Like the parent branch will always be impure. And in Haskell, as in many applications, we have this main concept, and the top level of Haskell, you will be able to do all kind of effects. And this is something that Alan Turing showed, or back in the days when he was writing his PhD thesis under Alonzo Church, which is like the forefather of lambda calculus. So what he showed is that we're able to write in Turing-complete languages the same kind of applications that we can write in lambda calculus, which is something that Haskell is built on. So this concept of effects, right? So what I discover working with Haskell is that, okay, why should we have this notion of global effects? So every part of my code should be able to interact with everything. For me, that doesn't give sense at all, because just because I want you to do some kind of effects, why should I allow you to do all kind of effects, right? So I have this example where I say, well, we want to send some confidential data to a database, but we don't have the manpower at the company, so we need some kind of subcontractors, right? So we want those people to write that part of the code, but how do I ensure as this person that this code will not be sent to their own servers and they will be misused, right? So this is like why I'm talking about this restriction of effects. There's this package called SS Decorator. I use it all the time when I do these kind of talks, and this is like the maintainer of this package. He decided to whoa, don't click. He decided to log every single time that you pass your sensitive information of your public-private keys. That's being logged directly to his own server. So my assumption here is that just because I use your open source free library, it doesn't mean that you have the right to actually keep my private and sensitive information, right? This happened a few years ago. Very recently, like again, everything related to password, you always see this kind of data injections or malware, whatever. So this is the Ruby library called strong password. So this was a bit more dodgy because they don't know what happened, because it was able to inject itself to call something paste bin. So this is a bit problematic because the tools we're using right now, we don't have any way of controlling this. And this is why I say that when we talk about cybersecurity, we're just this guy with the coffee there, like the dog, and we just look, yeah, this is perfectly fine, right? But we know that at some point it's going to bite us in the ass and we're going to end like the right side of the picture. And we can say whatever we want, like, yeah, cybersecurity, well, we're not good at doing our work in the IT community, but also in the real world, as I say. This is actually my neighbor, her storeroom in the basement. So somebody actually tried to get in and steal stuff. So she called for a professional to install a new lock, right? So, I mean, this is a hacker camp, right? So anybody here with a Phillips screwdriver can actually go down, remove 3 screws, take whatever they want and put it on again, right? And nobody will notice that you actually visit that place, right? So this is the real world. I don't know how it is, but I don't have any kind of mechanisms to limit bad practice. But in the IT world, which is the one I'm working in, we have this concept with this tool called monads. And I'm not going to go into deep in a technical or in a theoretical description, because I can see some PhDs here from my own old school university. So this is not what it's all about. But what I try to do is I try to make some kind of analogy to people who don't know how to code and doesn't know this language. So the way I try to explain this in a way that it gives sense, you can say that those 2 realms of code that I mentioned before, code that has or branches of code who has purity, and branches of code who has side effects. How do we actually ensure that data goes back and forth with those 2 separated realms, right? So there's this concept of monads, and a lot of people mention this word as a really bad word, but let's just take the word for what it is. So you can also think of it as just like a structured way of representing like calculation, right? And it's like in a sequential way, so you have to wait till this actually, this actually goes through, and then once that went through, you can actually take the next part of the steps and so on and so forth. And if something actually doesn't work, it will actually come out of this bridge and represent like a sound state of what you're actually trying to calculate. So this bridges that I'm trying to make this analogy about. You can go again and say there's a thing about the limitation of side effect. And this is what I discovered with Haskell, that by using this powerful construct, I can actually limit the side effects based on this monad thing. So another example is, this is the one we're going to see a bit like a very simple example in code. So the thing is, I want to make an application, and I want to ensure by design that my application only accesses a specific page. So if I have to access a specific page, I have to go over the internet, right? So that's an effect, right? Then I really want to have this content of the page. I wanted to show it on an output device, which can be the console in this case. That should be another effect. And I also want to put in a timestamp. So I want to see that 2 hours ago I went into this web page, I downloaded it, and then I printed it to the terminal. So we have 3 effects, right? This is actually a real Haskell code, and like I say before, like this main method, which you will see in both C and C++, and you will also see it in Java and C# and so on. So for the people who don't understand Haskell, the only thing that's specified here is like a signature. So it says like the main method is able to do all kind of effects. What I do with this approach that I'm using is that I say I actually bind this main method to my own granulated main method. So now instead of having all the effects, I actually limit it to 3 single effects. We wanted console output to print the page. We wanted a timestamp to actually show when I retrieve the page, and then I just want a specific website URL. So So this is actually 3 small IOs interaction with the real world compared to everything. So this is like in Haskell, you have design of this kind of constructs, and in the next slide I will show the implementation. But if you use this kind of statically typed programming languages, you have some kind of notion that's called an interface. So the only thing here in the design, we tell it that in order for us to print to the console, we will need one of these bridges that can actually go from those 2 realms, and you only need a function that is going to output. So this is why I call it out. And that will take a string. So this is the signature I expect you to implement when you're, or that you actually implement when you inherit my interface. Yeah. So you're just gonna get a string and you're going to do some kind of effect. And the same thing with the timestamp. Oh, you can get the time right now, and you can also get like the date of today. And the same thing with the website. So we want some TLS, so you can connect to secure websites. We want to be able to send a request, and we want to get some bytes, and sometimes we don't even want to get the bytes. This is the implementation. So we just make an instance of this powerful interfaces that I'd mentioned before, and we just set the output to the standard output function in Haskell. We do more or less the same for the date and the specific I/O, and the thing that's important here is that I actually restrict the HTTP client to only be able to do relative requests. So my application is bound to a specific website for the whole lifetime of this application, and when you use this application, you only be able to use a relative URL. So I know you will always be inside this domain. So what we do here is that we actually stay away from this red thing, which is all kind of effects on all code branches, and we just stay with those 3 effects. So this is a pretty simple example, and let's see if we can do this code thing. So this is actually a real-world application that's running. So as with many programs, you just have to define a module, and in this case it's main, but the important thing here is that you need to export this main function so it can be executed by the operating system when it runs this application. I define some effects, which is more or less designed like I did here. I will show you in a bit. Then I use some standard built-in libraries from Haskell, which allow us to use byte strings and also the TLS manager. I wrote my own network representation of both request, HTTP request and HTTP response. I borrow Galois' JSON parser, and I made my own parser for HTTP request and responses. And then I define like the main of my application is like the API and also like the interaction with those 2 services. So as I showed before, my main application, which can do everything, I just limit it to this granulated function. And you can see here in this granulated function, I have a few more effects than actually in the one I was shown in the slides. So I want to get the environments of my machine. I also want to get this server, which is a web server that I also implemented. I want to get access to this TLS manager. I want to get access to the OpenStreetMap service I wrote, and also like to some timestamps, and finally also to the Norwegian Met. So the way to read code in Haskell is that it's more or less like reading from Bash. So you will say, well, try to get from the operating system the port that I actually specified as an argument when I called my main function. So this is more or less like this thing that we will pipe it, like you do in Bash. We will pipe it into a lambda. This is what we use when we code in functional programming languages. I don't know if you can see it, but I cannot make this any bigger. Sorry about that. And it's a bit blurry on the top. Sorry. So what I do is I want from the query, or like the arguments of the main application when I run it, I want this port, and I also want the path for the binary. Then when I have those 2 values, I call this lambda, and I call a new function where I just start the web server. I give it the port, I give it the path to the binary, and then I will start this application. So already here you can see that the application I'm going to start has 2 fewer effects than actually the granulated function, because I just needed effects to retrieve the port and to retrieve the path to the binary. So now we actually recursively in another code branch, and here we can have the TLS manager, so we can ensure that we communicate over TLS. We have access to the OpenStreetMaps, the timestamps, and also to the Norwegian Met. So again, this concept of piping like in Bash. So right now we are running in this loop, so we will actually spawn an application, and we can just try to run it. So just to see what I will do is I have this web server running, and I will just feed it with by using curl, and I will just send like the data, which will be like the CD of Gelsted, Middelfart in Denmark, and I will connect to my own service. I'm not going to communicate with the OpenStreetMaps or the Met directly from the curl application. So we just run it. And we can see that, well, you should be able to say yes or no if you look into your own phones. If it's like 22 degrees right now, I can see the sun. So that's probably right. So the thing we are doing here, just a second, is that we're actually sending, in this application that is looping, so we can see that we connected, then the server is going to ask us for the information, and whenever it serves us the information back, it's going to disconnect us. So this is actually what's happening. We pull the context, like the data, like this binary string out of the web server. Now, then we have the input in form of bytes. We would like this incoming input to be translated from a byte string into a JSON object, and that JSON object, we can represent it in our data representation in Haskell. So once we have our data representation in Haskell, we have the city, right? So the Norwegian methodology, I cannot say it, the Norwegian Met service doesn't work with city names, it works with longitude and latitude coordinates. So this is why we need to ask first OpenStreetMaps, hey, we have this city name, can you please give us these coordinates? So here you go, you get the city, we pipe it in, we get the coordinates, and I call this function where I provide it with a timestamp because I would like to instantiate this representation of the temperature combined with the date that we actually ask. So you know, oh, I asked this service like 10 minutes ago, 2 minutes ago, and this was actually the temperature that you told us. So once you have the temperature, we can take it back, and now we need to do the other way around. So we have our data representation in Haskell. We need to convert it into a JSON, and the JSON we need to convert into a byte string. Once we have the byte string, we can push it back to the client, and then we can disconnect. So this is incoming function, which I say takes a byte string, and either it gives us an error in form of a string, which we will print out, or otherwise it will give us the city. We connect to the OpenStreetMaps, and you can notice now this one doesn't have any effects. This is what we call the pure branches of Haskell, so we don't need to take too much care of this. But this one, we don't really want to send too much information, so what I did here is I restricted this code branch to only be able to communicate with the URL from the OpenStreetMap. So let's say I send too much data or irrelevant data, it will always also, yeah, I might say something wrong. But the point is that we can only send the city directly to the OpenStreetMaps. And let's say, like I said before, we're too busy. We don't have the time to implement this part of the code, right? So our subcontractor or our freelancer or whoever it is, he has to comply with that signature. So either he sends the data that we give him to the OpenStreetMaps, or otherwise we're not able to build this binary. And I will show a bit in a few minutes just why this holds what I'm seeing here, right? So just for the sake of it, again, more or less the same with the methodology. Oh, Norwegian Met, I cannot say it, sorry. And again, outgoing, we just give it like the data representation and we get a byte string out of it. So the point is, what if our contractor, he's like, I don't really want to be nice. I don't really want to retrieve this ISO timestamp from your server. I just want to invent it, right? I want to do it statically, right? So let's say this one. And this is when you code in, for example, OCaml and so you use this concept of let define a value and then you actually use it on the other side of the in. But Haskell has this concept of where, so you can actually write your code and just put your values and afterwards you can just define it. So the only thing I did here was that I actually hard-coded this value of time to epoch. So now let's say what will happen when I try to build this. Now I'm actually, because my signature tells me that I need to have interactions with the TLS manager, the OpenStreetMap, the time the timestamps from the operating system, and the Norwegian Met. But already, when I try to build the application, it actually says, you have a redundant constraint. You're actually telling me that you're going to use some effects, but you're not using it. So you actually lied to me. And when you lie to me, Haskell says I cannot build a binary. So this is why I say, just by specifying the effects, you have to actually use the effects. It's not that you are not allowed to use many effects or many more effects. It's like you have to use the effects that I specify. So this is why it's so important, is that I designed the application and I expect you to follow my guidelines. And most of you maybe have recognized this Emacs, and it has a powerful, I don't know how to call it, application running under the hood that actually makes it easy to write Haskell code. So it's already telling me in the EDI that, you have a redundant part of an effect, so you probably should remove it or do this again. So now we should be able to build it. And I might have to stop the server too. So I know a lot of people say that Haskell is a bit difficult to read and it's a bit complex, but I was sitting yesterday as the judge of this Jeopardy, and I saw this Vim script, and I haven't seen anything as horrible as that in my whole life, so I don't know if Haskell is worse than that, but if I just take how difficult it is to implement the domain model of, for example, the OpenStreetMaps. So I just go in and say I defined a data representation, and this is called like a record, which could be compared to a class in Java or in C#. And I only tell it that it should be auto-implementing the interfaces of data and typable, because if it do that, I'm able to just call it with the JSON library from Galois. So I know that it's going to send a lot of information, like the OpenStreetMaps, but I'm only interested in two properties. The rest is not relevant for me. So this is the only thing I specify. And did it build? Yeah. So if anybody remember, and I cannot see my mouse, so there. So if anybody remember from the first slide, which will be impossible, that hexadecimal number, and I will come a bit back afterwards with this, you will see how this is also very important with what I'm talking. So yeah, all possible effects to only the effects that we actually specify, and you have to use them. That's the important part as well. So this actually is well known in information security and computer science as the principle of least privilege, or deprivation of pulp. And it's more or less like where you make a process, or you have a user, or you have an application, and it must only access the necessary information and resources, and which are necessary for its actually legitimate purpose. So you shouldn't give in too much, you shouldn't give in too less, you should give it exactly what it needs. And this is, I hope you can see like the mapping between those two things that I'm doing. And this is the powerful thing actually discovered with Haskell is like, among very few languages, I try also with Idris and so on, among very few languages actually able to do this at compile time. And if we recall, this thing about compile time is that we translate some code into some binaries. And it's a very powerful thing, this thing about transforming source code into binaries, because if we don't comply with this recipe or design that we provide, we cannot build these binaries, and we cannot build these binaries, we cannot ship them. So if we cannot ship them, we don't have all these problems that many other people have. So like I talk with other people who don't use Haskell, and they say, well, we use C and we use sandboxes. So the problem I see with C and sandboxes when they tackle pulp is that everything they find is actually at runtime. So let's say that you have made something similar, right? But you forgot to limit the access to hard drive, or you forgot to limit the access to the network. You will only discover that whenever somebody tells you that, oh, there's an issue. We're actually able to communicate with the network. The thing about Haskell is that we're not even going to build the binary. So we will tackle this up front. And this is my more or less like, oh, this is really cool, because if we are able to granulate these effects and we're able to use this kind of methodology, right, what I will do is I will just use my time to design the application and then implement. I will just design my effects for my application, bind it to my application here, and then just implement the effects that I expect everybody else to use, right? So when I have done that, I can just say, oh, you take care of the database, you take care of the connection to this internet website, and you that. And I know, I don't care who I will outsource this to, right? They have to live up to the requirements of the design of the application. If they don't do it, whenever I press compile in Haskell, we just say, I cannot build. You don't comply with the design. So this is why I say, I more or less don't care who I will outsource this part of the code. And with many tools that come from academia, sometimes because you need to make them useful in the real world, you take some kind of shortcuts, right? So in order to increase performance in some part of the Haskell code, you can use this thing where you can actually bypass this very strict notion of separation between pure and impure code in Haskell. So there's also a way to say, well, I don't want to bypass that. So whenever I'm building my application, I would like people to comply with my recipe. And now to the part where it's actually relevant. And I find it relevant for myself because, like I say, I'm trying to provide like a software methodology or some kind of a framework to be used whenever you want to create application that actually complies with the EU GDPR. So for the most, I always use this blog post from this guy called Tim Walters. And he's a guy who has no legal education whatsoever. So he just wrote the law, as many of us. Hey, I wrote it in 3 different languages just to see if it was that crazy. It's not. So the thing is, it's just like say, well, data minimization, all this gives sense to him, right? Because this is how we should be doing software, right? So yeah, we should be doing it with data minimization, able to demonstrate, this gives sense. Well, the data protection or the government comes and want to see whatever we're doing. We need to demonstrate to them that we're actually complying with what they're saying, or we're actually doing what we expect to do, right? So everything that touches personal data, and yes, the GDPR is only related to personal data, so no, I don't expect anybody to rewrite everything in Haskell. But if you have some personal data, this could be a possibility to be used. So every technology, this is the important part, should be designed to use the smallest amount of data, shortest possible, so on, exposing to the fewest eyeball, and so on and so forth, and then delete it, right? So you can see in my application here, there's no way that the data can go any way. I mean, I don't even allow it to write to the hard disk. That's totally removed from here. So I can even remove this of console output, so I cannot even print it to the console. So there's a lot of ways to limit exactly what is exposed here, right? So there has been some people are waiting for a bit of fines from the different data protection agencies, and it's actually the ICO from the UK which are actually beginning to give a bit bigger fines than the rest of Europe, and they're expecting to give the British Airways, who had like a big data breach, and they lost a lot of information from their customers, and the size is 183 million Great Britain pounds, and the Marriott Hotels, which is an American company, is going to get fined as well in the UK because they did more or less the same. So this is like, well, you can actually make software in this way, and you can always argue with the ICO, hey, this is our intention, and because we ensure that all data is communicated securely over TLS, we know exactly at all given point in time that it's been here, here, and here, and then we saved it encrypted to a data source, right, or data storage. So just to summarize up a bit, I hope I actually showcase you why this concept of effects impurity actually is smart in some way and what it's actually bring to the table, because I didn't know that a few years ago, and now I'm actually just like, wow, this is actually pretty nice. Restricting effects, as you can see here, so we just say our application, we don't want it to do it, all the kind of effects, and now it's a bit limited, yes, and the further we go in the code branches, we actually limit the effects for that part of the code branch. So this is pretty cool as well. Yeah, cybersecurity. Everybody involved in IT in general actually know that, well, we work with some not ideal tooling, and it's not because we choose them, it's sometimes we get them imposed. And when you get something that is not good enough, well, sometimes you have problems, right? So this is nothing new. This principle of least privilege, pulp, is something that we see all the time with Docker and sandboxes. But what I find it really, really powerful with Haskell is I can actually do it at compile time, which is like everybody who likes types knows this is actually where you can get it up front instead of you having to wait for end user to tell you that you did a bad piece of work, right? Designing and outsource, and this is what I say, we can even do it to people who have bad intentions. So this is for the managers. Oh, now you can actually outsource the code to everybody. You shouldn't be afraid of people injecting stuff into your code bases. Yes, this is like, the reason I actually found this was because I was trying to push the limits with regard of this GDPR legislation. So data protection by design and default, which is Article 25, and previously known as privacy by design. So most of the people would do this. It's not because they actually respect citizens' rights. No, they just do it because they don't want to get fined. But what I bring to the table is, and Amelia, she's a really, really, really clever person. But what I find a bit lacky for her talk was that she actually told us that we might be able to solve this GDPR by doing this Article 40 and 42, where we have to take those certification, and we get a paper that say, yeah, we comply with the GDPR, and it's just a piece of paper, right? I would rather have it built into my system so I cannot do it, and the people that actually get to my team cannot do it because they will actually break the design of the application. I don't know if Holger's here. No, I think he already took the train. So Holger and one of the other hackers who used to come to BornHack, Shimin Luo, they have been working on this project called Reproducible Builds for the Linux Foundation. And I would really, really appreciate that at some point in this, and the rest of this hacker festival, that you actually go into this website and read why it's so important with this reproducible builds. Because if you have reproducible builds, you will always be able, like you can see here, I'm running NixOS, so this number, really, really big hexadecimal number, is exactly the same as this one. So just so you see I'm not lying, clean. So what I will do here is I will clean stack, and I will delete anything related to stack in this subfolder. So you can see stack, stack, stack. So let's clean it. Now everything is gone, so I don't have a binary I can run. There's nothing. And let's say I will build it again. So we should expect, right? If we have reproducible builds, we also have reproducible hashes, right? So we should expect the exact same number. And this is important, right? Because if we have this binary running, and I was going to show the example of Google or Amazon or Microsoft, but because none of them are here and I can see a red fedora, I will actually use the example of OpenShift. So if you have your binaries running in a Docker container at OpenShift, Red Hat, then you will always be able to say, well, my binary is this one. And the thing about Docker is that they don't have this notion of reproducible build, so I made some kind of script that will actually tell me that the binary that I'm actually building in this container will have every time the same binary and also the binary hash. And if we look into this one, it should be matching as well. Yes, 5E0. So when I put in this code, you might be able to recreate the binary of the Docker, because this is what is common for everybody. But you probably will not be able to get the exact binary number of my NixOS, because my NixOS setup is a bit different from everybody else. It's because I install Haskell and Stack in a very peculiar way. So that's the thing, yeah. And I think that was it. So, any questions? Tools, yeah.
In one of your examples, you showed that if there were effects that you had specified in the type that you did not use, the result would be an error.
Oh, yeah.
I don't think that's a reliable feature, because, well, first of all, it's only an error because you told the compiler to treat warnings as errors. Normally, that's a compiler warning. And
yeah,
second, it's very easy to artificially use that constraint anyway by just adding a local binding that you never use for anything. Then there won't be a warning even.
That's actually a fair point. So the notion of effects in Haskell is that when you use this kind of a representation, you actually say, I might do an effect, right? I might do an effect.
Exactly.
So it's a bit like what's called Bloom filters, right? So you might get a false positive thing.
Yeah, which is probably fine. I mean, so it guards against malicious code doing things it shouldn't do, but it doesn't guard against lazy code that doesn't do anything.
That's a good point. Yeah, that's a good point. Yeah. So we still get like all the malicious code out, but yeah, good point.
So you show limiting or sort of keeping track of what effects you have within the program, but has there been any effort to sort of post-compile, determine what the program needs from the operating system, and then add additional checks, like with seccomp or with, I don't know, I think the BSDs have different privilege limits?
So the thing is, I rely, this is why I'm using this kind of operating systems, because if you go into this website, I think it's like, well, I was using CubesOS before with Debian, and Debian is 94% of all packages for that operating system are reproducible. This is the work of both Holger and Shimin. Those two were actually developers from the Debian community. And also NixOS is one of those distros that actually have high level of reproducible builds for the packages. But I don't know if all the other Linux distros has.
Well, I'm saying.
Oh.
I'm asking if within the Haskell community are there projects to take some sort of declaration of effects at compile time and then then sandboxing later on. Like say I was to replace the binary. You know, I know the binary is guaranteed to work in this constrained environment, and then I enforce that another way.
Yes, and that's a really good question. So what I will assume is that we're able to have this reproducible build, right? So if I'm able, as a contractor, as a government, as a university, go take the code from your company. If I'm able to build it based on your design, I will sign it, right? So if I sign it as a government or as a private company or as a hacker activist, when I go into, for example, let's say OpenShift, support this kind of concept of Docker with this kind of methodology, right? So I will be able to read on that Docker container here that this is signed by a public organization. It's signed by a hacker community and by a hacker activist and maybe by a big private company, right? So I know when I will access this kind of Docker container, there's several people that, if there was just that organization, I will not trust it. But it's because it's those companies combined, I would trust them. But like myself, I will not use my signature to trust software that doesn't comply with this technology, right? So yes, you will have always to have this extra notion of signature or whatever, because you never know. Once you send a binary to somewhere else, you never know if it's that's the thing that's running, right? That's not something I can solve here.
So you mentioned this as sort of a way to outsource things and then not have to trust the people writing the code. Yeah. And I think maybe it's like, I can totally see how this can help with like unintentional defects, and it can help you guarantee that the code you're writing is actually doing what it says, and it makes refactoring easy and all this kinds of stuff. But I think related to something like the GDPR or something, you will run into this sort of out-of-band problem that you have to specify the interface that people have to follow at such a granularity that like either you make it so permissible, like write any data to the console, or like write to this web server, and then that web server is AWS and you can do anything. Yeah. Like that it's too permissive, or it becomes so specific that it either becomes restrictive, or you've basically written the program as the specification. So yes. Like I'm a little bit skeptical of like that this will actually help you sort of, okay, I can just specify my interface and then I can outsource my code to anyone, and I will know because my compiler tells me that I live up to the GDPR. That's probably a bit of a strong claim for this. Yeah.
So this is why I come with this notion. I will never say I'm able to prove mathematically because I have a mathematic background. I will never say that, but I will say I will be able to show you, and this is based off the reproducible builds. So in order for you to modify the code to get the same exact hash, you really have to do some kind of magic, right? Because we all know that once you SSH A 256, like this binary has, it's almost impossible to get the same again just by modifying a comma or whatever it is. So that's a pretty difficult task. But I think
that's a different claim. That's just saying I can guarantee you that the binary I'm running actually corresponds to the source code. Yes. Which is an amazing property. Don't get me wrong. It's just
no, like but it's more or less this is what you say. So what I try to avoid with this is that just because I tell my subcontractor that they should like implement something, I will actually disallow them to use libraries like this, because this library actually leaks. It shouldn't be able to send to the website, right? What it should be doing is make some nice colors from my console. So when I take this one in, I can say, yeah, you can see some nice color in your console when you run this for the log. Yeah, that's perfect. But I will never allow your code branch to send to some website. It's not going to happen. So this is the kind of errors this kind of approach can remove. And this is why I say that, well, if those people that are going to implement this part of the code have bad intention and they want to take this kind of data and send it all the way around, I can actually limit, I can actually remove it totally. Yeah. And if they don't comply with this, we're not going to make a binary. And if we don't make a binary, it's not going to get shipped. I understand the question behind is, okay, so now we have this binary. How do we know that this binary complies with this, right? So we know the thing about reproducible builds. And this is where we need some kind of trust mechanism. Red Hat can sign them, a university can sign them, a hackerspace can sign them. Now we have 3 independent, really well-known organization that actually put the name that the design we see actually matches with this reproducible build. But I don't know if I'm answering the question.
No, it's like that's a different claim. There's some classes of things you can protect against. For example, like an SSH daemon connecting to a web server.
Yeah.
But you cannot say this icon at compile time guarantee that this application will send phone numbers but not birth dates to this web service. Like these kinds of sort of data quality properties that the GDPR,
you actually can.
But then you have to specify that in the interface, and then the interface becomes so complicated that you've basically written the application.
So now I think I understand what you're saying.
So then you don't gain anything from outsourcing because you already had to write the whole thing to get the interface.
So I know if I just design this, if I just give the signature to the people who are going to implement this, right? the only thing I'm giving it is the city. So that's the only thing they can send, right? They're not able to interact with the rest of the world. They can just get my input value and they can just send it to that website. That's the only thing they're allowed to do here. So I know at a given point that they can only send the city information.
But you can tell the compiler that it's a city and still write your name in the text.
It's
Otherwise, you have to do like regular expressions or like match the data.
So this is also one of the nice things about Haskell is that, just a second, when I define my data representation, because I don't implement the interfaces of showable, it will never be able to get translated into text. So this data container thing can only be used with this JSON component that I'm using, so it cannot be used with anything else. But I don't know if I'm answering the question, or we can probably take it afterwards, yeah.
Can I have a question?
Yeah.
I kind of get what you're getting at here, which is that you can use these types to say, well, we only allow leaking the city or whatever, and you can you can shield the constructors, you can't put arbitrary text in the constructor and so on. I think that makes a lot of sense, and I think in terms of complexity, you would probably have like a big repository of, say, GDPR relevant types, and you could all import that. So every time you write an application, you don't have to sit and model like blah, 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 this is private. You just go like, well, import everything from datatilsynet and say, okay, these people define what is sensitive and what isn't, and I just use those definitions. And
Yeah.
I get that part, but I still think that if I'm a malicious contractor, I could still use these valid things that I am allowed to sort of leak to the public to signal the actual secret things I do want to get out. I mean, I can just sort of in Morse code put like that city, that city, that city, that city, and then I can encode my actual payload in valid types and invalid stuff that's at some point observable. Kind of like if you have a timing attack on something, you know what I mean?
Yeah, yeah.
And that's very
yeah.
hard to defend against, I think.
So the thing is, and this is why I didn't want it to add the randomness from the operating system, but it's a bit difficult to make timing attacks if you don't have randomness. Well, I can remove the time, so you don't have the possibility to say rerun this in 2 or 3 seconds, right? So this is what you want to do with the Morsing, right? So you send dots, what's called slash dot slash slash slash. So I can remove the time. Now you don't have time in this function. So
yeah, I'm not talking about random stuff, timing attacks per se. I'm talking about covert channels where through the sort of nice checked API, you can still say, oh, I either return that city or that city, and use that as 0 or 1.
Yeah.
And then I have a binary channel to the outside world that consists of valid types, but I might be encoding the password or whatever inside that.
Okay, yeah.
That was my point as well. Like you can use this to sort of catch defects that happen by mistake.
Yes.
But if you want to do it against malicious actors, then it becomes like a weapons race between your ability to write interfaces that are correct and the sort of contractor's ability to get around it by being creative.
Yes. Good points.
Yeah, and you can bound that, right? You can say if you only allow this thing to return once, it can only leak 1 bit of the password.
Yeah.
Boom.
Are we done?
Sorry.
No problem.